Andersen. Today we're going to be starting a new unit on transformations of functions. We're specifically going to look at quadratic functions, and then eventually you'll look at graphs of functions using your calculator as a tool to help you there. So today we're going to look specifically at reflection and mapping. Okay, so the first mapping, or the first reflection we're going to look at is the reflection in the x-axis. So the x-axis, we of course know, is here. And if we were to reflect, say, a point, say the point 3, 2 in the x-axis, it's just going to reflect directly over the x-axis as if that was a mirror, and we'll be at the point 3, -2. So we can reflect points, we can reflect lines, we can reflect entire functions, we can reflect shapes. Just to give you another idea of what that looks like, say we have the point -2, 1. That point is going to reflect over the x-axis at -2, -1. So notice the x value stays the same in the points, and they're reflecting over the y-axis. And what changes will just the y value. The y changes to the opposite. So had we started at 2, -1 down here, and reflected over the x-axis, that y value would have become the opposite, so it would have then become positive. So x stays the same, y goes to the opposite, and that's what we call the mapping. So xy goes to x -y is the mapping for a reflection across the x-axis. And we represent that as a function with negative f of x. If you think about it, f of x is equal to y. So if we're making y negative in the mapping, by doing negative f of x, we'll be creating a reflection across the x-axis, and we'll look more at that in the future. Okay, a reflection in the y-axis. So we'll do the same points. Let's start with 3, 2. If we're going to reflect that in the y-axis, it's going to become -3, 2. And if we have a point -2, -1, reflect that in the y-axis, oops, that becomes a +2, -1. So notice here y stays the same when we're reflecting over the y-axis, but x is going to change to the opposite. So the mapping is xy goes to a -x, +y, and this is what's happening to the function. Basically, the x is becoming negative. We can see that in our mapping. So instead of putting a positive x into the function, we'll put a negative x into the function, and that will give you a reflection across the y-axis. And again, we'll look at that more. Reflection in y equals x. So y equals x is a line that goes through the y-intercept of 0 and has a slope of 1. Okay, so that's y equals x. We're going to reflect our points across that line. So if we've been working with 3, 2, it's going to go to the point 2, 3. And if we have the point, let's see, yeah, let's choose -2, 1. That's going to go to 1, -2. Okay, so what's changing here? If y equals x, the mapping is going to be the x and y are going to switch. Notice we went from the point 3, 2, and then x and y switched, and it became 2, 3. Same with our second point. -2, 1 becomes 1, -2. And honestly, we could call these points, like if we call this point B, the reflection is going to be called B prime. That little dash means prime. And same here, if we call this original point A, then its reflection is called A prime. That's a good thing to know. Okay, corresponding mapping, xy is going to yx. X and y are going to switch. So if you think about the equation y equals x, well then if y equals x, then x is going to equal y. So the they're just going to switch with each other. And to get that mapping for a function, to get that reflection over y equals x, we'll actually do the inverse of the function. If you can remember, when we studied inverses last unit, the reflection in the line y equals x is going to be given to you by the inverse of the function. So you're basically just going to switch x and y, solve for y, and then graph that new function. Reflection about the origin. Okay, so we've got the point 3, 2. Again, we can call that A. If we reflect something about the origin, we're going to have the negative x. And this will be our A prime. So it's like it's done a spin of 180 degrees. Goes to, our mapping is that xy goes to negative x, negative y. So point 3, 2 is going to go to negative 3, negative 2. The point, let's see, let's do negative 2, 1. That'll be our b. And then b prime is going to be positive 2, negative 1. And again, it's just a reflection of, it's like a rotation of 180 degrees. And this is the reflection in the origin. And again, the corresponding mapping is xy goes to negative x, negative y. So we have the point negative 2, 1. That point's going to go to 2, negative 1. So x and y are both going to become the opposite. Okay, we can also reflect shapes. We're going to reflect this triangle in the y equals negative x line. So if you can imagine that's a line with a y-intercept of 0, and it has a slope of negative 1. So we can reflect each shape, or each point individually across this line. So if A is here, when we reflect it across that line, we're going to get A prime here. So originally A was at negative 2, 1, 2, 3, 4, and now it's going to negative 4, positive 2. So notice we've switched x and y and made them the opposite of each other. So that is our mapping. xy is going to go to negative y, negative x. Okay, so if b is positive 2, 1, 2, 3, 4, 5, 6, 2, 6, b prime is going to be negative 6, 1, 2, 3, 4, 5, 6, negative 2. Okay. And C is 3, 2, so that's going to go to negative 2, negative 3. Okay, and then it's just a matter of connecting our points. Kind of. Okay. So there we've got it. We've reflected our triangle ABC across the line y equals negative x, and that gives us the reflection A prime, B prime, C prime, that triangle. Okay, we can do the same with a line. So if we reflect this line about the x-axis, our x-axis is here. We're going to use that as our mirror, basically. So any point on the x-axis is going to stay there when we do the reflection. And we can reflect each point individually. Let's see. Notice we've got a y-intercept just above 1, 2, 3, 4, 5. So we'll have a y-intercept just below negative 5. Somewhere in there. And we can keep doing that with each individual point. And notice this point here is 3 down, so it'll be about 3 up, and so on. And then we can connect points. Okay, so that's our reflection in the x-axis. Okay, we can do the same thing with the y-axis. So if we're reflecting in the y-axis, this point is going to stay exactly where it is. And then we'll reflect this point here. 1, 2, 3, 4, 5, 6. Something like this. And this point can be reflected over here. So something like that. We've got a reflection in the y-axis, and the line y equals x. If you can imagine y equals x, and it's here. And basically, when we reflect over the line y equals x, we're finding the inverse of this original line, of this original function. So let's graph that in green as well. So any point on the line y equals x is going to stay right where it is. So we've got 1, 2, 3, 4, 5. We've got a y-intercept of 5, so that's going to become our x-intercept. 1, 2, 3, 4, 5. And our x-intercept of 6 becomes our y-intercept of 6. And we've got 6 all the way up to 10. So this point is negative 6, 10. And when we reflect that across the line y equals x, we're going to get 10, negative 6. X and y are just going to switch places. And this point here is at 10, negative 3. So when we reflect that across the line y equals x, we're going to have negative 3, 10. Okay. Okay, then it's just a matter of connecting the dots. So the green line is the reflection across y equals x of the red line, and it's the inverse of that function. Okay, we can also use mapping to denote dilation. So dilation is a type of transformation. Notice these have all been reflections or translations. We can, better reflections. So these have all been reflections, and now we're talking about a different type of transformation. Transformation just refers to change, and that's called dilation. So we can blow up the entire shape, we can make it larger, or we can make it smaller, or we can do that to a single point, also to a function. So if the original point is a1, 2, and we want to find a prime, that point undergoing this dilation, so it tells us the mapping of that dilation is x is going to go to negative 3x. So 1, 2, 1 is going to be multiplied by negative 3, so we're going to have negative 3 times our x, which is 1, and y is going to be multiplied by 5. So we'll have 5 times our y, which is 2. So 1, 2 is going to go to, let's see, a is going to a prime. Okay, so 1, 2 is going to go to negative 3, 10, and this is a prime. Okay, so that's undergoing a dilation. A translation is sliding a point. So it starts at one point and we're going to slide it to another point. For example, we're at the point 1, 2, and we want to move that point 5 units to the right and 3 units down. So the mapping of that, x, y, we always start with x, y with our mapping, and that's going to be translated 5 units to the right, so x plus 5, and 3 units down, so y is going to be minus 3. So if we start with 1, 2, we're going to have 1 plus 5 and 2 minus 3, or in other words, 6, negative 1. And if we call that point A again that we started with, then this one will be A prime. Okay, that's it. Thank you.